Hi everyone, today we are presenting our project on deploying an application using Azure Kubernetes Service. Our team members are me as Manpreet Kaur, Pramchand Kaur, Kamaldeep Kaur, Armandeep Singh and Priyanka Rani. This presentation will walk you through the technologies we used, why we choose Azure, our deployment architecture and workflow, best practices we followed, and the challenges we overcame during this project. Now let's get started. Let's start with an overview of the application. Our application is built using the three main technologies: Kubernetes, Docker, and Azure. Firstly, the Kubernetes is a system that automates the management and orchestration of the application containers. It ensures that our app runs smoothly, scale efficiently, and can recover from failures. Docker. This is used for containerize our application. Container packages everything needed to run the app, include nodes, libraries, and dependencies, making deployment consistent across environment. Third, Azure, the cloud platform where we hosted our application. It provides all the services required for scalability, security, and reliability. Our application had the following key requirements: scalability, reliability, and ease of maintenance. Scalability handles increased user demand without performance drop. Reliability should remain consistently available without downtime. And ease of maintenance, update, and troubleshooting should be simple and efficient. Now the question arises, why we choose the Microsoft Azure over the other cloud platforms. We choose Microsoft Azure as a cloud provider due to its comprehensive and reliable services. The first one is Kubernetes built-in support. Azure Kubernetes Service allows us to deploy, manage, and scale our Kubernetes cluster with ease. This minimizes the operational complexity. Secondly, high availability and scaling feature. Azure ensures that our application can scale automatically based on our user demand while maintaining high uptime. Thirdly, integration with CI/CD pipelines. Azure works seamlessly with tools like Azure DevOps to automate our build and development process, saving time and reducing error. Fourthly, Azure Container Registry. This provides a secure way to store, manage, and retrieve our Docker container images. This slide illustrates the architecture of our application deployment on AKS. We started by creating a resource group to logically group all resources required for the deployment. Next, we set up an AKS cluster which acts as the environment for running our application containers. Thirdly, the Azure Container Registry was used to store and manage our Docker container images. Then, Kubernetes configuration files were applied to deploy the application on the AKS cluster. Finally, the application was exposed to the internet and we accessed it through an external IP address. This architecture ensures high availability, scalability, and secure management of our app. Now let's talk about the deployment workflow. Here is a step-by-step breakdown of our deployment process. Firstly, log into the Azure CLI. This gives us access to the Azure services from the command line. Secondly, resource group creation. We created a resource group to organize all our Azure resources. As you can see in the screenshot, we created a resource group with the group name of E. Now after creating the resource group, we will set up AKS cluster. By using the Azure CLI, we set up cluster where our containers would run. Next, create and login to ACR. We configured a private container registry to securely store our Docker images. Now come to the next step, build and push the Docker image. The application was packed into a Docker image and uploaded to ACR, and then apply configuration files. We used Kubernetes YAML configuration file to deploy the application and define how it should run on the cluster. You can see in the screenshots too. Now the final part is access the application. Finally, the app was exposed through an external IP address which we used to verify the deployment. And here is the result. So, during the project, we followed several best practices to ensure a secure, reliable, and efficient deployment. The first one is security. We used a private Azure Container Registry, which is ACR, to keep our Docker images secure. Secondly, role based access control was implemented to ensure only authorized team members had access to the resources. Second practice is reliability. We used Kubernetes health checks to monitor the application status automatically, restart failed container. Next, rolling update allowed us to deploy changes without disrupting the application. Third practice is CI CD integration. Azure DevOps was used to automate the build and deployment pipeline. We set up automated triggers to initiate build and deployment whenever new code was pushed. Like any project, we encounter some challenges, and here how we address them. Firstly, cluster configuration. Initially, setting up the AKS cluster and understanding its configuration was complex, but we used Azure documentation and tutorials to guide us step by step. Next, we have the container image issues. Some containers build failed during the process, so we debugged the Docker files and tested locally before pushing to ACR. Thirdly, service access. Accesses the application through the external IP required troubleshooting. So, we verified the Kubernetes service configuration and ensured proper ingress rules were applied. These challenges help us gain a deeper understanding of Kubernetes and Azure services, preparing us for more advanced deployment in future. In conclusion, I can only say that this project successfully demonstrated the deployment of a containerized application on Azure Kubernetes service. It taught us the importance of teamwork, proper planning, and continuous learning. Thank you so much.